Hi, I started a new video series where I will teach you how you can write combinational logic in HLS and then later export into the Vivado. Okay, so for today's lecture, this is the first lecture. I will show you how you can write this half-headed code in HLS and then how you can transport uh, its IP to Vivado and how you can use in Vivado ID. So first of all, I will run HLS. I have this 21.2 version. Let it open. I will create new project. Okay, I selected a folder name of half header. Okay, so this is just project name. Okay, half header dash HLS. Then the top function of our project is half header. I don't have any uh, files now, so I will let it go as it is. No test bench. Here you can select the clock, the part or FPGA, and you can name it here as well. I will keep these things default. First, I will add my project, my FPGA board for this project, then select and finish. Here you can add sources. I will add new sources. This is my .cpp file. Okay, I can add header file .h file. This is the simplest project, so there is no need of header file, but it is good to write as an practice. Then testbench.cpp file and testbench header file. Okay, now I have created four files, two for sources for testbench. In the header file, I will use pragma once as a header guard. It is good thing to in, make in practice. Include ap-int in your header file. Either you can skip this one. Okay. Here first I will add my header file of header. Okay. Then write my top function name, which is half header. I will use this single bit input, okay, and single bit output for sum and carry. Sum occurs when A XOR with B. Carry occurs when A and B. So I will use Boolean for single bits. First Boolean is A, next is B. Okay, remember in HLS, whenever you declare the output, you will use the pointer operator. Okay, for sum, bool, carry is also my output, so I will use pointer for carry. Okay, then the simple logic is pointer sum is equal to A. You can either use X or B, or you can use the symbol. In the symbol we use this one for XOR. Then carry is equal to 1. Either you can use AND B, okay, or either you can use AND B. So I will prefer to use symbols now. The one thing is remaining here. You have to declare these input and outputs declaratives. For example, input A, interface type, source file, and then go to the AP none. This defined there is no handshake. This defined this is simple wire type. No buffer, no FIFO, no memory. It's AP none. It defines and the output is input a simple wire. Okay. Same thing I will do for the B. Same for sum. Okay. And you have to insert directives for the function as well. There is no handshake for required for this function. Okay. Yes, you're done. Now I will write its test bench. To write test bench, I will call the header file of header or h file, and from here, from the source code, I will just copy this one and put here. Okay. Either you can do this thing in the test bench CPP file, or it is good practice to keep such thing in header file. In the test bench CPP file, I will include the half header test bench header file, and now a stream just to see input and outputs. Int main group, then represent all the input outputs you have used in your main function. First, I will put a 0, b is 0, then I will call the function. My function is this one, okay? Operator function where a, b, as it is pointer type, so I must write like this, okay? Then std out of a is equal to then b is equal to sum, and then carry is equal to cherry minus std. Okay, I will check all the possible combinations of A and B. So I will make a copy of these. Okay, first both A and B are 0, 0, 0, then A is 1, B is 0, then B is 1, B is 0, then both are 1. Okay, let's see simulation. Okay, here you can do this C simulation first. Here you can see A and B are 0, 0, sum 0, carry 0. If A is 1, B is 0, sum is 1, carry 0. B is A is 0, B is 1, sum is 1, carry 0. Both A and B are 1, then sum is 0, carries 1. Okay, then it's functionally correct. So how I can do this synthesis and then C and RTL code simulation? I will do that. First, I will do the synthesis. Okay, in synthesis, it let us know that how much hardware it's going to use. It is using the four lookup tables. Okay, then after synthesis, I can do this core simulation. Core simulation means C and RTL simulation simultaneously. For here, you have to do done trace all. Okay, you can use either Verilog or VSTL. Now, after this completion, I will show you how you can see your signal on Vivado simulation. Then I will export it into the Vivado, and then let's see. Now it's passed the close simulation, so you can run the view here. It will open your Vivado IDE. It's opening the Vivado IDE. Okay, here it will automatically will open the waveforms, the outputs, okay, the C inputs. So here you can see and that A both are 0, A is 1, B 0, B1, A 0, both are 1, and the out- outputs as well. Okay, so after that we will export it. Okay, it's exporting its IP, and later on can use in Vivado. Here in the simulation, in the solution, you can see it's Verilog code. Yeah, it has written Verilog code like this for half a day. Okay, it exported successfully. So I will open the Vivado. Create a project here. I will select the directory and directory. Okay, and this is my path header. Okay, this project name. Board. I will select the same one. Reliable. It's not necessary. Select same board. Okay, then you can add your repository from here. Okay, it must be insert this, so you can see your repository is added. So I'll just of header, just creating a block design, and you can add your HLS created IP block of header here. Okay, this is A and B, this is sum and carry. This board is just created by default by the HLS, so you don't need to take care of these. Okay, I'll just verify this module. Okay, then I will do simulation. I didn't write its test bench, but I will use force simulation. I will give it force values. For example, in binary, initially a 0, force constant 0. Okay, if both are 0, then this. If I will change a to 1, okay, then you can see this. If a is 1, b is 0, sum is 1, carry is 0. Then I will put first 4 microsecond and one for constant. This is 1, this is 0. Okay, you can see this is 1, this is 0, B is 1 and sum is 1. Now I will do the both A and B 1. B is already 1, is 1 again. You can see this A, B are 1, 1 and here sum is 0, carry is 1. So this is the method you can generate your uh, IP from HLS. Okay, this is the simplest and first lecture about this um, HLS tool. I will create many more videos. Please comment and share this video, subscribe this channel, and write down in comment which combinational circuit you want to implement. Thank you very much.